Right, let's jump straight into this explainer and uncover how a totally unsung industrial hero is out there literally saving lives in disaster zones and fundamentally reshaping green architecture as we know it. I mean, we rarely think about the actual building blocks of our homes, right? At least not until we desperately need them. But today, we're looking at a true, real-world revolution in materials.
Imagine the absolute chaos following a devastating earthquake, or the sheer destruction in a conflict zone. In those critical moments, the saying goes, time is life. So ask yourself, how on earth can people possibly construct safe, reliable shelter immediately, especially when heavy machinery is completely destroyed and professional builders are nowhere to be found? Well, the answer isn't pouring concrete. It's actually something entirely different.
To answer that pressing question, we're going to track the incredible journey of lightweight calcium silicate board across 5 key areas today: the Global Housing Challenge, a lightweight building revolution, 3 stages of rebuilding, the nanotech secret, and finally, green living beyond emergencies.
Starting off with Section 1, the Global Housing Challenge. Let's talk about the sheer scale of the global housing crisis, specifically looking at disaster-prone and high-risk regions, like those along the Belt and Road routes. In places like this, housing isn't just about having a comfortable place to sleep. It's a fundamental pillar of human survival and social stability.
The absolute crux of the issue comes down to this stark contrast. Heavy, slow, traditional building is practically useless when a sudden emergency hits. I mean, you need cranes, cement mixers, skilled crews, none of which you have. On the flip side, lightweight prefabricated housing changes the whole game. It relies on super simple tools. It actually empowers ordinary people, the occupants themselves, to rapidly assemble their own shelters when professional help just isn't an option.
Moving right along to Section 2, a lightweight building revolution. Because what we're witnessing right now is a massive, seismic shift away from heavy cement and brick toward materials specifically engineered to be smart, light, and incredibly resilient.
And the craziest part? This material is not just some temporary Band-Aid solution. Whether we're talking about upgrading overseas refugee camps to instantly provide dignity and safety, or constructing highly earthquake-resistant schools in Sichuan, China, lightweight calcium silicate board acts as a continuous, vital lifeline through absolutely every single stage of a community's recovery.
Which brings us to Section 3, 3 stages of rebuilding. Because rebuilding isn't just a one-and-done event, it's a phased process. And the engineering of these boards beautifully adapts to utilize 3 distinct, specialized building systems.
You literally walk through the timeline of rebuilding here. You start on day 1 with emergency rapid response shelters. Then, as weeks slowly turn into months, you progress to comfortable medium-term housing upgrades. And finally, you culminate in permanent, structurally resilient homes and hospitals.
Let's break down the exact mechanics of how this scales. First up, the single-wall system. It's literally just a 20 to 22 millimeter board slapped on a simple frame. Anyone can build it, which is perfect for an emergency camp. Next, you level up to the double wall. This uses 2 thinner boards with a cavity in the middle, letting you pack in thermal and sound insulation for transitional schools or clinics. And finally, the VST system. This uses a robust 24 millimeter board as permanent formwork. You actually pour reinforced concrete right into it on site to create incredibly seismic-resistant permanent apartments. It's brilliant how seamlessly the engineering adapts to the timeline.
Okay, Section 4, the nanotech secret. You're probably thinking, how exactly is this possible? How on earth do you make a board tough enough to hold wet, heavy concrete, but light enough for a civilian to carry through a disaster zone with one hand? Well, let's look at the science. Enter Qinglong New Materials and their absolutely incredible breakthrough. They somehow managed to drop this material's density to an astonishing 0.65 grams per cubic centimeter. Just to put that into perspective for a second, water is 1 gram per cubic centimeter. So this material is incredibly airy, yet remarkably structurally sound.
And because it's 45 to 55% lighter than traditional low-density boards, a single panel can easily be lifted with just one hand. Just think about what that means for logistics in some remote, hard-to-reach area. You don't need heavy lifting equipment, which slashes your installation costs by up to 30% right off the bat.
The big secret behind this seemingly impossible lightness is called inorganic nanomodified whisker technology. Now, I know that sounds like a dense, intimidating piece of engineering jargon, but honestly, it's a pretty elegant concept to visualize once you break it down.
Just picture these microscopic, nanoscale whiskers acting like a tiny three-dimensional steel rebar mesh woven entirely inside the board itself. Thanks to this invisible, internal scaffolding, the material achieves a flexural strength of over 8 megapascals, meaning it bends and absorbs massive shock without snapping.
And that microscopic mesh doesn't just give it physical toughness, it makes the board practically invincible to heat. It can survive direct exposure to a 1300 degrees Celsius flame. That's over 2,300 degrees Fahrenheit, by the way, without a single crack. Whether it's an emergency shelter or a high-rise hospital, that specific kind of fire protection is exactly what saves lives.
Finally, Section 5, Beyond Emergencies, Green Living. Let's step out of the disaster zone for a minute. Because as we look at the 2025 push for industrial lightweighting and massive global zero-carbon policies, we are seeing this exact same crisis-tested technology quietly infiltrating our everyday lives.
The ultimate environmental win here actually kicks off right at the factory level. The whole manufacturing process uses this highly intelligent zero-waste circular loop, where absolutely every single offcut gets recycled. Combine that with a super-efficient steam curing process that shortens production down to just 6 hours, you're reducing carbon emissions by over 2,000 tons annually for every single production line. That is massive.
So why does all this matter to you directly? Because this stuff isn't just reserved for bunkers and refugee camps. This material is likely in the walls around you right now. It's used for maternal-grade, totally odor-free custom home interiors because it has zero formaldehyde. It clads industrial exhaust ducts, surviving 400-degree acidic gases for over 15 years. It's in fire doors holding back infernos for over 4 hours. And it's heavily relied upon in solar-compatible prefabricated modules, reducing a building's entire structural load by a third. It is literally quietly building our green future.
Which leaves us with one final, pretty wild thought to take away from this explainer today. As global challenges just keep mounting, from climate change to rapid urbanization to natural disasters, could these unseen, ultra-lightweight material innovations actually be the ultimate foundation for securing humanity's safe, sustainable future? It really makes you look at the walls around you in a completely different light, doesn't it? Keep exploring and always keep questioning the world built around you.